clearly?
Yes, sir.
Okay, all right. So we were discussing properties of Fourier representation. Properties of Fourier representation. I said yesterday. I think we discussed linearity and symmetry properties. Okay. So we will be discussing today. We'll be discussing periodicity. Periodicity. Okay. So I'll take one case: discrete time Fourier transform. So discrete time Fourier transform. Discrete time Fourier transform is always periodic. Is always periodic in omega. Omega is the frequency. Okay. With a period of 2 pi. With a period of 2 pi. And mathematically, we can say, therefore, mathematically, we can say then that x of e raised power j omega plus 2 pi will be equal to x of e raised power j omega. We should remember that all sinusoids, they are periodic. All sinusoids are periodic. Whether it is cos or sine, they are periodic with a period of 2 pi. Okay. We know that signals like cos theta, it is a periodic with a period of 2 pi. Similarly, signal like sine theta, it is a periodic with a period of 2 pi. Or even representation of Euler's function e raised to power theta. We know that e raised to power theta, if it has a magnitude of unity, okay, then say for example this is theta, so this will be angle 0 degree, this will be pi by 2, and this will be pi, this will be 3 pi by 2, and this will be 0 or 2 pi. So after 2 pi, all exponential functions, they return to the original place. So they are also periodic with omega. This is all omega, okay? With omega, with omega equal to 2 pi, with omega equal to 2 pi. So for a period of 2 pi, all sinusoids are periodic. So we can then say e raised to power j theta will be equal to a raised to power j theta plus 2 pi. That is also the same thing. Similarly, we can write down x of e raised to power j theta plus 2 pi will be equal to x of e raised to power j theta. Okay. Or in more general way, we can write down x of e raised to power j omega plus 2 pi k, where k is an integer, where k is an integer, it is equal to x of e raised to power j theta or j omega. Okay, where k is an integer, where k is an integer. So this is the periodicity property of Fourier, discrete Fourier transform, discrete time Fourier transform. Now see, if we try to analyze it, how it is true, then we can write down its proof. Now we know that discrete time Fourier transform of any signal x of n, x of n, okay, x of n is a discrete time signal. It is equal to x of e raised power j omega. This is the discrete time Fourier transform of any signal x of n, which is equal to x of e raised power j omega. And that is equal to summation of n equal to minus infinity to plus infinity x of n e raised power minus j omega n. Okay. Now see, we have omega here. If we substitute omega equal to omega equal to omega plus 2 pi k. Okay, 2 pi k, because it has a periodicity of 2 pi. And k means k is equal to 0, 1, 2, 3. It means at 1 pi, 2 pi, 3 pi, 4 pi, the periodicity will be maintained. It will be maintained. Okay. So if we substitute therefore omega equal to omega plus 2 pi k in above equation, then there will be no problem because it will still maintain the periodicity. Why it will maintain? Because see, if you have a sinusoid, this is 2 pi period, okay? Then at 4 pi, this is 2 pi here, this is 4 pi here. So it will have same periodicity, even at even numbers or integer multiples of 2 pi. So everywhere there will be periodicity maintained. So it doesn't matter whether we add this omega with 2 pi k, उससे कोई असर नहीं पड़ेगा. So what will be we having then in above equation? If we will, which equation I'm talking about? I'm talking about equation this one. Say for example equation 1. Okay. So then I will have x of e raised power j omega. I had e raised power j omega. Now I will have omega plus 2 pi k. Omega plus 2 pi k. Okay. So that will be one thing on the left hand side. On the right hand side, I will have summation of n equal to minus infinity to plus infinity x of n e raised power minus j. It was j omega n. Okay, it was j omega n. So I will write down here omega plus 2 pi k, then n. Okay, then n, which can be further simplified as summation n equal to minus infinity to plus infinity x of n e raised power minus j omega n. When bases are same, powers are added. Okay, so when powers are added, we can separate their bases also into e raised power minus j 2 pi k n, 2 pi k n. Okay, so this is what will be there. Now see, we know from Euler's formula that e raised power j theta, e raised power minus j theta, e raised power minus j theta, it is equal to cos of theta minus j sine theta. Okay, so this is from Euler's formula. We know that. So therefore we'll be having that, and whereas in this equation that we have here, this n and k, n and k, whereas in above equation, that is equation 2, it may be noted that both k and n, they are integers. Okay, they are integers. So ये जो n and k है, what is the value they can take? They are integers. They can take any integer value. Okay, they can take any integer value. So therefore, from equation 2, okay, we can write down e raised power minus j 2 pi k, e raised power minus j 2 pi k n. Using Euler's formula, we can write it down as cos of, yes, what is the angle? Tawhida, what is the angle? 75. 75. What is the angle here? Cos of theta. What is the theta? Mehvish, what is the angle?
So minus j omega n.
Minus j omega n?
So minus j 2 pi
Minus j 2 pi
kn.
kn, that is the theta. Farhat Iqbal.
जी सर.
What is the angle here? Cos of theta. Theta क्या है बेटा?
So 2 pi kn.
2 pi kn is the correct answer. 2 pi kn. So it is 2 pi kn. Minus j नहीं है because minus j is a separate thing. Okay, it is a separate thing. So theta is 2 pi kn. Then you have minus. Okay, Farhad, then what is the next term? What is the next term I should write down, Farhad?
माइनस जे साइन माइनस जे
हाँ, sine
थीटा के बदले आएगा 2 पाई के एन.
2 pi kn. That's correct. Okay. So this is what is e raised power j theta from Euler's formula, and I have separated this thing. Okay, I have separated this thing. Now see, since k and n, they are both integers. Okay, since k and n are both integers, since k comma n are integers, they are integers. Therefore, what is cos of 2 pi kn? Cos of 2 pi kn. Cos of 2 pi kn will be equal to 1. Cos of 2 pi kn will be equal to 1. Why? Because see, this is cos theta. This is cos theta, and this is one period. This is 0. This is pi by 2, and this is pi. This is 3 pi by 2, and this is 4 pi by 2 means 2 pi. Okay. So, so this is 1, 2 pi. 2 pi is the period for this entire duration. Now, if you multiply 2 pi by n, k will be an integer, and n is also an integer. So k into n is also an integer. तो आप इसको किसी भी number integer से multiply करेंगे तो you will obtain different cycles. Will obtain different cycles of cos. Okay, will obtain different cycles of cos. But at the end, cos of 2 pi, it is equal to plus 1, and cos of pi, it is equal to minus 1. So cos of 2 pi, so this is 4 pi. Okay, this is 2 pi, this is 4 pi. Similarly, this is 6 pi. So uh, cos of 2 pi, yes. So n times 2 pi will be always equal to plus 1. N times 2 pi, yeah, k into n times 2 pi will be always equal to some number times 2 pi. तो चाहे ये कोई भी number हो, it will be always equal to 1. That is why I said that cos of 2 pi kn will be always equal to 1. Okay, it will be always equal to 1. And similarly, I have another term, sine of 2 pi kn. Okay, sine of 2 pi kn. Sine of 2 pi kn. I'll ask students what is sine of 2 pi kn equal to. See, this is sine theta. This is sine theta. So this is 0, this is pi by 2, this is pi, 3 pi by 2, this is 2 pi. Okay, so another cycle will be like this. This means 4 pi. Third cycle would be like this. This means 6 pi. Okay, so what is sine of 2 pi kn? I will ask Ubaida. Ubaida, what is sine of 2 pi kn, beta? 69. Ubaida? Ubaida? Mumin Bashir?
जी सर.
What is sine of 2 pi kn?
Sine of 2 pi.
Kn.
Sir, 0.
It will be always 0. That will be always 0. Why? Sine of 2 pi here. So see, this is 2 pi. So sine of 2 pi, it is 0 here. At 4 pi, it is also 0. At 6 pi, it is also 0. Okay, so this is 0. Sine 90 is 1. Sine pi by 2 is 1. Sine pi by 2 is 1. So therefore, sine of 2 pi kn will be 0. So these terms will be true. These two terms will be always true for any value of k and n, because both of them are integers. K and n are integers. Okay. All right. So if cos theta, cos 2 pi kn is equal to 1 and sine 2 pi kn is equal to 0, what is then e raised power minus j 2 pi kn equal to, it will be equal to cos 2 pi kn is equal to 1. Then you have minus, then we have minus j times sine of 2 pi kn is 0. So please remember that e raised power minus j 2 pi kn will be always equal to 1. It will be always equal to 1. Okay, it will be always equal to unity. So if that is true, then we can substitute it. E raised power 2k 2 pi kn will be equal to 1 in equation 2. Okay, we can substitute in equation 2. So if we substitute in equation 2, what will be we obtaining then? I will write down here. So equation 2 is there. I'll write down here. Substituting in equation 2. Substituting in equation 2. So if we substitute in equation 2, then we will have x of e raised power j. So we have e raised power j omega plus 2 pi k. Okay, omega plus 2 pi k. J into omega plus 2 pi k, that is equal to now summation of n equal to minus infinity to plus infinity x of n from equation 2 e raised to power minus j omega n into 1 into 1. Okay, so that will be equal to x of e raised to power j omega plus 2 pi k will be equal to, what is this thing equal to? This thing is equal to x of e raised to power j omega, x of e raised to power j omega, x of e raised to power j omega. So this is x of e raised to power j omega. So therefore we can try, we can say that discrete time Fourier transform. What is that? See, this is here. So we were about to prove this thing. Okay, so we were about to prove this thing, or this thing here is one and the same thing. We were about to prove this thing, that there is a periodicity in discrete time Fourier series, a discrete time Fourier transform with respect to omega equal to 2 pi. So if we change omega by 2 pi or 2 pi k, तो इसके जो Fourier transform है, there will be no impact on, there will be no change in the Fourier transform. It will be still x of e raised power e to the power j omega. So we have proved it here also. Okay, is it fine? रिजवान बेटा, आपको ये समझ में आया?
जी सर.
कोई क्वेश्चन तो नहीं है?
नो सर.
What about 24? 24 is here.
Yes, sir.
कोई सवाल तो नहीं है बेटा?
No, sir.
मोमिन,
जी सर.
ठीक है बेटा, ये कोई सवाल तो नहीं है?
नो सर, ठीक है.
Okay, so this is periodicity. Okay, this is periodicity. Second would be time shifting property. Time shifting property. Let us discuss time shifting property. Time shifting property. अब देखिए, जो ये पीरियोडिसिटी है, मैंने ये दिखाया इन व्हाट केस, डिस्क्रीट टाइम फोरियर ट्रांसफॉर्म के केस में. तो अब मेरे लिए ये पॉसिबल तो नहीं है मैं हर किसी क्योंकि वी हैव 4 डिफरेंट टाइप्स ऑफ रिप्रेजेंटेशन, फोरियर ट्रांसफॉर्म, फोरियर सीरीज, डिस्क्रीट टाइम फोरियर ट्रांसफॉर्म, डिस्क्रीट टाइम फोरियर सीरीज. मैंने एक में दिखाया है, डिस्क्रीट टाइम फोरियर ट्रांसफॉर्म में. तो आप खुद अपनी जगह पे बाकी 3 पे देख सकते हैं कहाँ कहाँ ये वैलिड है. दैट इज जस्ट एन असाइनमेंट टू यू. ओके, सो we'll go for another one. It is fourth property. Time shifting property. Okay, fourth one, time shifting property. Now see, this property states that if a discrete time signal is shifted in the time domain, in the time domain by certain number, say for example n naught, or if if a discrete time signal is shifted in time domain by n naught samples, okay, then its magnitude spectrum remains unchanged. So when you shift a discrete time signal in its time domain by n naught samples, its magnitude spectrum remains unchanged. Okay. However, there is a change. However, the phase spectrum is changed by an amount of minus omega n naught. Okay, minus omega n naught. So what does that mean? That means that if you have a signal, okay, that is x of t, you have a signal x of t. If you want to find the discrete time Fourier transform of the signal, then we will obtain x of e to the power j omega. Okay. Then if we shift this signal, so we have not x of t, sorry, it is x of n. Okay. So this is not x of t, this is x of n, because this is a discrete time signal. Then if we shift this signal, x of n, if it is shifted by n minus n naught, that means by n naught it is shifted. Okay, so there is a shifting in the signal. Then if we take the discrete time Fourier transform of the shifted signal, then what will be our Fourier transform will be e raised to power minus j omega n naught times x of e raised to power j omega. Okay, so where n is an integer, where n naught is an integer. So this is what it means. So let us see how it happens. Suppose we have a signal here. So this is a proof of this thing. Okay, suppose we have a signal x of n, discrete time signal. We want to take discrete time Fourier transform of it. Discrete time Fourier transform of the signal, it will be x of e to power j omega. Okay, so this is the discrete time Fourier transform. And what is discrete time Fourier transform equal to? Let me write it down here. So what is x of e raised to power j omega equal to? It is equal to summation of n equal to minus infinity to plus infinity. Then x of n, this is the general form of Fourier transform, discrete time Fourier transform, e raised to power minus j omega n. E raised to power minus j omega n. Okay. Now see, therefore, what will be the Fourier transform of a shifted signal? Discrete time Fourier transform of x of n minus n naught. Okay, x of n minus n naught. X of n minus n naught. It is a shifted signal now. So it will be equal to summation of n minus n naught equal to minus infinity to plus infinity. Then instead of x of n, you will have x of n minus n naught. Okay, so we'll have x of n minus n naught, because now the signal is x of n minus n naught, and e raised to power minus j omega n. So let me not write it down here n minus n naught. I'll write down the general form n equal to minus infinity, but it is basically, we will substitute it later on. It is n minus n naught now. Okay, now see, if we put
Excuse me, sir.
जी.
सर के ऊपर आपने ये लिखा ना ये सर x of n minus n naught सर जिसका ये e power of minus j omega n naught into x of e power of j omega सर वहाँ मत आएगा e power of j omega n.
Well, you are talking about this equation?
Yes sir.
हाँ, क्या बोल रहे हो आप?
यहाँ पे आपने लिखा ना e power of minus j omega n naught into e power of j omega, तो यहाँ में e power of j omega n आएगा।
नहीं, j omega n
Yes sir.
just a second. So you are saying e power, yes it is e power j omega n.
Yes sir,
It
यही
is,
मैं कह रहा हूँ।
अच्छा आप यहाँ पे नहीं है, यहाँ तो j omega ही है।
Okay sir.
This is j omega, ये यहाँ n नहीं है, this is only e power j omega because this is Fourier transform representation, इसमें e to the power j omega है, n तो नहीं आता है, n तो यहाँ आता है इसकी फॉर्मूला में, so n comes here in the formula, वहाँ पे नहीं है, ठीक है। तो let us try to find out, हम तो आगे भी देखेंगे, वैसे तो यहाँ तो यही है, there is no n there, okay। So if we try to expand it, we will have to simplify it, put n minus n naught equal to m. Let us put n minus n naught equal to m, okay? If n minus n naught will be equal to m, then what will be n equal to? Then n will be equal to m plus n naught. Rearranging this equation, n will be equal to m plus n naught. And what will we obtain? We obtain this thing. So discrete time Fourier transform of x of n minus n naught, n minus n naught will be equal to summation of so it was जो जनरल फॉर्मूला है उसमें बेसिकली आपका n है, ठीक है, क्योंकि अब उस वक्त आपको x of n हुआ करता है। What is the general formula? This is the general formula. See, the general formula is like this. General formula is x of e raised power j omega, it is equal to summation of n equal to minus infinity to plus infinity x of n e raised power minus j omega n, क्योंकि यहाँ जो आपका होता है you have x of n, that is why the limits are for n. Now since we have now n minus n naught, okay, n minus n naught, अब जो यहाँ लिमिट्स आएंगे इस स्टेप में discrete time Fourier transform of x of n minus n naught, तो वहाँ n minus n naught के लिमिट्स चेंज होंगे। So I will directly write it down m here because n minus n naught is equal to m, तो m ही की लिमिट्स हो जाएंगे चेंज, m equal to minus infinity to plus infinity. Rizwan, is it fine? ठीक है बेटा ये?
Yes sir.
Okay, बुशरा आपको बेटा ये समझ में आया?
जी सर।
Okay, fine. Now see, we had x of n minus n naught, okay, in equation 2 for example, here we had x of n minus n naught, so it will be x of m because x of m because n minus n naught is equal to m, n minus n naught is equal to m. Then we have e raised power e to the power of minus j omega, okay. Instead of n we will write down what is the replacement of n. Can somebody help me? What is the replacement of n?
m plus n naught.
M plus n naught, m plus n naught, very good, it is m plus n naught, so it is m plus n naught, okay, something like this. So if we will further simplify it, it will be summation of m equal to minus infinity to plus infinity, then it will be x of m, and it will be e raised power minus j omega, just a second, we have, okay, yes, j omega n naught into e to the power minus j omega m, okay. So we have base, when bases are same, powers are added, so when powers are added we can separate bases also, okay. So further we can write down this, we can simplify it, it will be equal to summation of, or it will be equal to, write down here, summation of m equal to minus infinity to plus infinity x of m into e raised power e to the power minus j omega m, and we are left with this term now. Okay, so this term will be taken out, this term, because there is no m present, summation इस पे apply नहीं होगा, it will be considered as a constant. E to the power minus j omega n naught will come out. Okay, it will come out. Now see, what is summation of m equal to infinity minus infinity to plus infinity x of m e raised to power j omega m equal to, that is all equal to x of e raised to power j omega. Okay, because it now resembles to the general equation. So it is, we will be having e raised to power j omega n naught into x of e to the power j omega. Okay, so what is this equal to? This is the discrete time Fourier transform of x of n minus n naught, or discrete time Fourier transform of x of m, because m is equal to n minus n naught. M is equal to n minus n naught. M is equal to n minus n naught. Okay, so this proves our expression. What was the expression at the top? Time shifting property की जो expression थी, that was here. ठीक है, जब हम discrete time Fourier transform निकालेंगे x of n minus n naught को, so we will be having e raised to power minus j omega n naught into x of e raised to power j omega. ठीक है, so we can now conclude that hence according to the above equation, according to the above equation, time shifting property states that delaying a discrete time signal by n naught samples or n naught units does not change its amplitude spectrum. Okay, its amplitude spectrum. However, it changes the phase spectrum. It changes the phase spectrum by how much? This is the magnitude. E raised to power j theta. Okay, e raised to power j theta. What is the theta? Theta here, theta is equal to minus omega n naught. So this is the change in phase spectrum. So theta can be changed by this phase spectrum. So this is the change in the phase spectrum. Is it fine? ठीक है ये बेटा? Binish, ठीक है?
सर एक क्वेश्चन,
हाँ बताओ.
जो इक्वेशन सेकंड है ना, उसमें जब हम इसको शिफ्ट करते हैं बाय n माइनस n नॉट, ठीक है ना, तो वहां पे जो हमने e टू द पावर रखा है ना माइनस j ओमेगा n, वहां पे तो आना चाहिए ना माइनस ओमेगा n नॉट से, अकॉर्डिंग टू द
वो हम
स्टेटमेंट.
देखिए, वो हम यहाँ पे बेसिकली ये कर रहे हैं सब्स्टिट्यूशन. आई एम सब्स्टिट्यूटिंग इट हियर इन द नेक्स्ट स्टेप. आपको दिखाइए यहाँ पे, देखिए ये इक्वेशन 2 एंड द नेक्स्ट दैट इज द सेम, इट इज वन एंड द सेम थिंग. यहाँ n माइनस एन नॉट है, यहाँ पे भी n माइनस एन नॉट है, यहाँ n माइनस एन नॉट है तो मैं यहाँ m कर रहा हूँ सब्स्टिट्यूट. यहाँ n है तो मैं n के बजाय m प्लस n नॉट कर रहा हूँ सब्स्टिट्यूट, बिकॉज आई हैव टू रिमूव द n नाउ. n इसमें नहीं आना चाहिए, इट शुड बी इन टर्म्स ऑफ m नाउ. ठीक है, डू यू अंडरस्टैंड व्हाट आई एम सेइंग?
यस सर.
ठीक है, तो यहाँ n को करना था सब्स्टिट्यूट, अब मैंने वो नेक्स्ट स्टेप में किया है. बाकी इसमें इट इज क्वाइट सिमिलर. So now we will be having fifth property. Fifth property is frequency shifting. This was time shifting. Okay, time shifting. This is now frequency shifting property. Frequency shifting. The frequency shifting property. Now see, frequency shifting property states that multiplication of a sequence multiplication of a sequence x of n, any sequence x of n, by some by e raised power j omega n, e raised power j omega. Just a second. Okay. So it states that multiplication of any sequence x of n by a number e raised power j omega n, which is basically a frequency dependent number, is
आपने ओमेगा नॉट लिखा
omega naught. Yes, it is omega naught, j omega naught n. E raised power j omega naught n is equivalent to a frequency shift, or is equivalent to a frequency shift, or I can say frequency translation of the spectrum x of e raised power j omega by omega naught okay. And we know that x of e raised power j omega is periodic. The shift omega naught applies to the spectrum of the signal in every period. Okay, so the shift will be okay. I'll just conclude it in a few minutes. ठीक है. So जैसे spectrum of e raised power x of e raised power j omega, we know that it is periodic with respect to omega. ठीक है. Therefore the shift will apply in the spectrum in every period. मैं उसको बताऊंगा. I'll plot the graph, then I will try to understand the sign. So let us first try to say what it mathematically means. Mathematically, whatever we have written above, it means that if we have a signal x of n, and if we try to find out discrete time Fourier transform of that signal, then it will be equal to x of e raised power j omega. Okay, this is the Fourier discrete time Fourier transform. Then if we multiply x of n by e raised power j omega naught n, ठीक है, अगर हम इसको इससे multiply करेंगे e raised power j omega naught n, which is to be multiplied input signal, then if we take the discrete time Fourier transform of that signal, its Fourier transform will be x of e raised power j, but it will be shifted omega minus omega naught. That is what will be the Fourier transform of this signal if we multiply any signal by e raised power j omega naught. यानी अगर किसी भी सिग्नल को e raised power j omega naught n से multiply करेंगे, it will result a shift in the spectrum. Okay, let us try to see what does that mean. First, we'll try to understand how this will happen. Okay, so we know that discrete time Fourier transform of x of n, it is equal to x of e raised power j omega, which is equal to general formula n equal to minus infinity to plus infinity, then x of n e raised power minus j omega n. This is the general formula. Okay, so therefore then discrete time Fourier transform of a signal which is multiplied by e raised power j omega naught n So therefore, its discrete time Fourier transform will be equal to yes, it will be equal to summation of n equal to minus infinity to plus infinity. Instead of x of n, instead of x of n, we have to write down x of n into e raised to power j omega naught n. That is my सिग्नल नाम ओके तो जनरल फॉर्मूला में होती है x of n अब यहाँ x of n नहीं है अब यहाँ x of n into e raised to j omega naught n है and in general formula you have e raised to power minus j omega n that is already present there okay then we can find out we can simplify this it will be equal to n equal to minus infinity to plus infinity x of n bases are same powers will be added so it will be yes e raised to power minus j if we will take common you will have inside omega minus omega naught into n omega minus omega naught into n is it fine Farhad बेटा ये ठीक है
जी सर
हमाद हमाद बेटा ये ठीक है ये
यस सर
कोई कंफ्यूजन तो नहीं है कैसे ये ओमेगा माइनस ओमेगा नॉट हुआ
नो सर इसको हमने कॉमन है सर आगे
हाँ व्हाट अबाउट अफनान अफनान को समझ में आया
Yes, sir.
ओके ठीक है बेटा ओके then we can say that discrete time Fourier transform of a signal which is e raised to power j omega naught n into x of n ठीक है यही सिग्नल है उसका जो discrete time Fourier transform है it will be x of e raised to power j अब हुआ करता था एक्चुअल फॉर्मूला में यहाँ ओमेगा ठीक है यहाँ हुआ करता था ओमेगा बट यू हैव ओमेगा माइनस ओमेगा नॉट सो इट विल बी ओमेगा माइनस ओमेगा नॉट now okay so this is what used to be there now you have here instead of omega you have omega minus omega naught so this is what is the discrete time Fourier transform okay so we can then write down e raised to power j omega naught n into x of n are Fourier transform. It is a Fourier transform pair or discrete time Fourier transform pair with x of e raised to power j omega minus omega naught. They are both pairs. ठीक है? तो अगर हम इनको if we will try to plot them, see this is how we can plot them. X of e raised to power j omega. So say for example this is x of e raised to power j omega. So I am trying to plot x Fourier transform. Okay, x of e raised to power j omega. It is the Fourier transform. Say for example, somehow we are able to plot it like this. Okay, let us not go into the details how it is triangular, but say for example, it is plotted like this. ठीक है, तो ये जीरो पे है ना? e raised to power j omega जीरो पे है. तो अगर ये जीरो पे है, मान लीजिए this is zero, okay? Then this is pi by 2. This is pi by 2. Somewhere here it is pi. Somewhere here it is 3 pi by 2. Somewhere here it is 2 pi. Okay, तो ये स्केल ऐसे ही बनेगी. स्केल बिल्कुल ऐसी ही जाएगी. Similarly here you have 0 pi by 2, then you will have somewhere here pi, then you will have 3 pi by 2 for example here. Okay, then somewhere here you will have 2 pi by 2, but they will be all in negative, so minus. ठीक है, तो e raised to power j omega का ट्रायंगुलर वेव है, ट्रायंगुलर प्लॉट है, वो है ओरिजिन पे एट जीरो पे. तो इसका दूसरा जो प्लॉट होगा, इट्स सेकंड प्लॉट विल बी एट 2 पाई. तो क्योंकि ये पीरियोडिक है, इट इज पीरियोडिक विद रेस्पेक्ट टू ओमेगा बट विद अ पीरियड ऑफ 2 पाई. तो ये जो जैसा है ये ऐसा ही आपको मिलेगा समवेयर हियर एट 2 पाई. 2 पाई पे भी आपको मिलेगा ऐसा ही. इसी तरीके से -4 पाई -4 पाई बाई 2 मीन्स -2 पाई. तो यहाँ पे भी आपको वैसा ही कुछ ट्रायंगुलर वेव फॉर्म मिलेगा. सो व्हाई आई एम ड्रॉइंग 3, ये तीन ही नहीं होंगे. वंस यू विल गो टू माइनस इन्फिनिटी टू प्लस इन्फिनिटी, ये बहुत सारे रिपीट होंगे और ये प्लॉट्स रिपीट होंगे एट n 2 पाई, n टाइम्स 2 पाई. यानी 2 पाई पे भी होगा, 0 पे भी होगा, 4 पाई पे, 6 पाई पे. व्हाई? बिकॉज e रेज़्ड टू पावर j थीटा e raised power j theta, it is a periodic signal. It is a periodic signal with a period of omega equal to 2 pi, theta equal to 2 pi. So this is x of e raised power j omega. Now the plot of shifted signal, which is x of e raised power j ओमेगा माइनस ओमेगा नॉट. ठीक है, ये है हमारी शिफ्टेड ट्रांसफॉर्म e raised to j omega minus omega naught. उसका प्लॉट कैसा होगा? It will be at omega equal to omega naught. Omega, when you have shifted signal omega minus omega naught, then it will be at omega equal to omega naught. तो आपकी जो ट्रायंगुलर वेव बनेगी वो समवेयर हेयर कहीं पे ओमेगा नॉट पे बनेगी. ओके, say for example this is 0 and this is somewhere here 2 pi, then you have somewhere here 2 pi plus omega naught. तो पहली ट्रायंगुलर वेव शिफ्टेड होगी, वो बनेगी यहाँ कहीं. हालांकि उसकी जो हाइट वगैरह होगी वो बराबर जो ऊपर वाली x of e raised for j ओमेगा वैसी ही होगी. तो क्योंकि एम्पलीट्यूड स्पेक्ट्रम में कोई फर्क नहीं पड़ता है, सिर्फ शिफ्टिंग हो जाती है. और दूसरी होगी 2 पाई प्लस ओमेगा नॉट पे. ठीक है, इसी तरीके से आपको लेफ्ट साइड से मिलेगा -2 पाई प्लस ओमेगा नॉट पे एक ट्रायंगुलर वेव. एंड देन इट विल बी इट विल गो ऑन. ये पीरियोडिक है, ये आगे होती जाएगी. द ओनली डिफरेंस बिटवीन दिस एंड दिस वन is that you have a shifted waveform. Because of frequency shifting, multiplication by e raised power j omega naught n has resulted a frequency translation of x of j omega. See what I have written. It states that multiplication of a sequence x of n by e raised power j omega naught, it is equivalent to a frequency translation of the spectrum by e raised frequency spectrum, that is x of e raised power j omega naught by omega naught. ट्रांसलेशन यानी शिफ्ट होता है उसको बाय ओमेगा नॉट. तो वो भी आपको यहाँ दिख रहा है. यू हैड प्रीवियसली दिस वाज एट ओरिजिन, the waveform was at origin, but here it is shifted by omega naught. It is translated by omega naught. Is it fine? किसी को कोई सवाल तो नहीं है? रिजवान बेटा, आपको सवाल तो नहीं है?
No, sir.
ठीक है ये?
Yes, sir.
Okay.